Welcome to the REDMANE data ingestion final presentation for summer 25-26. This is intake 14, and this is going to be a really interesting presentation. I've seen a lot of good collaboration here, so let's jump straight into it. Rachel, I think it's all yours.
Yeah. Okay, hello everyone. This is yet our final presentation with the data ingestion team. And yeah, we're very excited to share what we've done over the course of this intake. First, I'd like to start off with an acknowledgement to country. So we'd like to pay our respects to the traditional owners of the land on which we meet, the Wurundjeri Woi-wurrung people. We would like to pay our respects to elders past, present, and emerging. So in our presentation today, we'll be starting off with introducing our team and a high-level introduction of the REDMANE project. Then we'll be going into details of data ingestion and how our work fits into the overall ecosystem. We'll be discussing what our goals were, what each of us worked on, and finally we'll talk about our feedback for the internship and some suggestions for future intakes. Moving on to the next slide. So this is our team outline. Oh, I think you're muted.
So hi, I'm Jess. I recently graduated from the Master of Science Bioinformatics, and I mainly worked on refactoring the metadata generator script.
My name's Dylan, and I'm doing my Bachelor's of Science, majoring in Computing and Software Systems, and I was mainly responsible for the testing component of this intake.
Hello, my name is Manish, and I delivered demo critical updates for the metadata generator. I'm doing Masters of Data Science at the University of Melbourne.
And hi everyone, my name's Rachel. I'm in the Bachelor of Science, majoring in Maths and Stats, and I mainly worked on the HTML preview. Okay, so first we'll give a high-level introduction of REDMANE. And REDMANE was mainly created because of difficulties in providing a streamlined end-to-end research data management solution, especially when there are multiple data types and multiple organizations involved. And we can compare REDMANE project to a library ecosystem. So this slide shows a diagram of the entire project, and the data registry in the middle, which stores the metadata, can be compared to a library catalog that tracks books, so the data in this case, that are in different locations. So in this diagram, we have organization 1 and organization 2. And the project also provides tools such as on the right, the portals for data visualizations, and also access to the data from the researcher's point of view. And now I'll move on to the data ingestion specifically.
So we'll just go do like a quick user workflow of what they would experience doing data ingestion. So firstly, on the data registry website, the researcher would register a new data set. This would include like project name, location of the data files, the file extensions that they're looking to track, and the patient sample mapping. So a config and README file will be created from this information, and then the researcher downloads and moves the config and README into the directory on the local organization machine that has the data sets. And then when the raw data is generated for the project, the researcher will run the metadata generator that is installed on the machine. This produces two outputs, the HTML preview, as well as a JSON with the metadata output. The HTML preview allows for a visual inspection of the output to ensure that everything looks correct before the metadata JSON is then uploaded to the data registry, where it can populate the fields on a SQL database. And then the same happens when the data is processed, you run the generator again, and then update that metadata in the registry, and then same for when the summarized files have been completed. So this is just a quick demo of like running the metadata generator script.
So it's really easy once you already have the config file set up in the target directory. Just in the script, and then the target directory, press enter. It will print out the name of each file and the size as it's getting processed, the total size of the file, and then you have your outputs generated. So this is what the metadata JSON looks like, and then we have the HTML preview, where you can look at the files in a much easier way. And it shows you total number of files found, and then the file sizes, inspection ID, sample ID, and then the different categories of raw, processed, and summarized.
Yep. And then looking more closely at how the metadata generator script works. So we have like the functional requirements, such as the target directory and the file extensions of interest being the input, the ability for the script to scan the directory for files with the matching extension and exclude files that aren't relevant, to be able to extract the metadata, such as the file path and file size, as like being able to kind of estimate the amount of storage needed is important, as well as performing the patient to sample mapping, and then generating the output JSON of the metadata and the HTML. So the previous intake did create a script that kind of like met this basic functionality, but there's also like quality attributes such as like how easy it is to read the visual preview, like how easy it is to work with new file types and on new operating systems, how modular the code is for like maintainability and like having unit tests, reliability, like how it's able to handle unexpected inputs if it logs any errors, and then performance. So our team mainly focused on improving these aspects in our intake, and then I'll be passing on to Dylan to talk about our goals.
Yep. So our first goal during this intake was just to understand where the prior interns got up to, what they had completed, and just where to go from there. Alongside that goal, we just needed to get a better understanding of REDMANE as a whole, the higher level understanding, and yep, before we wanted to go into anything technical. The second goal was to strengthen the technical foundations by refactoring existing code. We just wanted to improve the structure, modularity, and portability of the repository so it would run more cleanly out of the box. The third goal was to begin implementing some proper testing practices. This meant by just introducing some unit tests and integration tests and just automating that process. The fourth goal was to improve the user interface and readability through HTML. This goal was pretty important for us because data ingestion's interface is for a lot of different entities. And because of that, we just wanted our outputs to be that much clearer. And I'll pass it back to Jess.
So one of the things we did was introducing a config file. So there's some information that's specific to each dataset, such as which file extensions we're tracking and the patient to sample mapping. So like what is a good way to transfer this information from the registry to the script? So previously variables were hard-coded in a file, and it needed to be changed each time you run on a new directory that had like different file extensions. And then patient sample mapping was also a separate file that needed to be loaded. So now we have a config JSON file that is specific to each project directory placed in that folder. So in the future, it will be created automatically by the data registry for download as a source of truth. And additionally, it also loads the patient sample mapping information. And the directory is a key as well that helps verify that it is in the correct folder. And because the format is a JSON, it opens up to API usage in the future. Additionally, we did some refactoring of the metadata generator script as well. So previously, the OS library was used for file paths, and that sort of like broke when used on different operating systems. So now we're using the pathlib library for it to be more OS agnostic. There were also individual functions for processing raw, processed, and summarized files, which resulted in free directory walks and quite a lot of repeated code. We've like made it more modular now, so the walk only needs to be done once, and there's just like one function that's called multiple times for extracting the metadata. And it also assumed that sample ID is the same as the file name without the extension, so it fails if it's not like an exact match. And now we're using regex, which is really good at like text pattern matching to search for the sample ID within the file name and as well as inside the file. And there were also some redundant features that increase storage. So for example, RO create, it would like create a research object that kind of like duplicated the data set and increased like the storage that was used, and it was removed as like this the we had compatibility, so it was no longer a use case for it. Yeah.
Right, moving on to some key features that we used. So originally our ingestion pipeline only accepted raw FASTQ and BAM files, but modern genomics and imaging pipelines also output summarized tables, like that of the gene expression counts that we used. Now these TSV and CSV files embed the sample IDs into the column headers, so we needed a way to extract them. So we added a counts TSV option and a new logic to update the local py script that reads the sample IDs from the TSV and CSV headers, then categorizes these files as summarized in our metadata, and also includes them in the output. Then we also created a synthetic dataset with counts tables and matching config templates to help our team rehearse the demo. This work means we can now ingest the gene expression data and other summarized metrics, making REDMANE ready for future imaging portals. Next, we also tackled reliability. Earlier versions had hard-coded defaults that were not really working well with the data. So missing config entries were silently ignored. To fix this, we built a strict validation function that checks for the required keys, raw, processed, and summarized extensions, and also sample to patient mappings. If anything was missing or malformed, the tool exits immediately with clear message, preventing bad metadata. We also implemented functions like the extract meta, extract sample name, and validate directory match to correctly then parse the sample IDs from complex file names and ensure files live in the right folders. We also developed cleaner prototype modules like config.py, filescanner.py, etc. in other branches and then merged the logic back into the main script. Those prototypes still remain available for future refactoring. Finally, we also wrote detailed guides, produced diagrams, and provided practice datasets so that the next cohort and other teams can pick up the tool without reading much code. Next slide, please. Moving on to the testing part.
Yeah, so as the code base evolved, it became clear that reliability depended largely on manual checks, as well as developer caution. This was because there were no existing safeguards to consistently verify that core logic behaved as expected. This meant that regressions could easily slip through as new features introduced. So to address this, I began by introducing some unit tests using PyTest, where the initial focus was not on achieving full code coverage, but rather on isolating and validating the most critical logic paths. Each test targeted a clearly defined success case or an edge condition or an error scenario, allowing individual functions to be verified independently of the entire pipeline. So once I had a stable base of unit tests in place, I extended this approach by laying the groundwork for some integration testing. So rather than testing components in isolation, I began validating small but realistic execution flows, such as processing a minimal input and asserting that the expected values were being outputted. This helped ensure that key modules worked together cohesively and not just individually. So the final step was having these tests run automatically through GitHub Actions. I did this by setting up a continuous integration pipeline, which just made a clean Python environment, installed all the dependencies, and automatically ran the tests on every push and pull request. After this, testing was no longer a manual step performed inconsistently, but rather an enforced checkpoint. So the result of all of this is that we could move away from relying on developer caution and reactive debugging and move towards a more systematic approach. So each change now produces a clear pass or fail signal. And I think more importantly, unstable code is identified before it reaches any other branch, and contributors can also receive immediate feedback. I'll hand it off to Rachel for the HTML preview.
With the HTML preview, as just mentioned a few slides ago with the whole enclosed system, on the right here, I've got a zoomed in version of the diagram. So after a user has run the metadata generator, which is installed on the local machine, the generator will return the HTML preview and the metadata JSON file, and the preview allows users to get a visual summary of the raw processed and summarized data. And then the researcher can confirm whether they will upload the metadata JSON file onto the data registry. And on the left, we can see the preview from the previous intake. And during this intake, we worked on changing the interface so that it is more cohesive with the design of the data registry. And to do this, we reuse the CSS styling done by the web dev team, and the final result is shown on the bottom left. And I can also show a quick preview. So this is what Jess also showed in the demo before, but it's got raw files, process files, summarized files, and it's also got quick stats of how many different types there are. And now we'll move on to the next slide, Manish.
All right, so here we'll just summarize what we delivered beyond the core pipeline. So to make the demo repeatable and make it easier for the next cohort to pick up, firstly, we worked on the demo readiness. We added guardrails so we catch issues early, clear config checks, and early failure messages. And we also aligned on sample to patient mapping convention so the demo ingestion behaves consistently. We also improved the human QA step. The HTML preview now makes it easier for researchers to sanity check what's going into the JSON. Second, reproducible examples. We created small practice datasets and config templates covering WGS, imaging, and counts so others can rehearse the workflow. And we also added edge cases fixtures like missing IDs, config folder mismatches, and counts files so we know the generator behaves safely. Thirdly, we worked on the handover and collaboration part as well by documenting what we did and produced the diagrams used in this deck. We also worked with the web development and the workflow teams to align expectations and share the sample data. Moving on to the feedback.
Yep. So the first point of feedback was that the documentation provided to us was a super helpful source of just being a learning point for us. We could refer back to it for anything we needed to know for REDMANE and more specifically data ingestions. So I thought that was pretty good. The second point was that the mentorship provided by Roland was super good. He was super responsive and supportive to any questions we had or anything we needed during the program. The third point kind of stems from the second point, but I can say that every meeting that I took part in during this program, I felt super comfortable in being able to ask any question I wanted to. And I think that's because of the safe and supportive environment that Roland has created. I also think that the expectation of having to ask questions during the meetings also helps people stay engaged with the program. So I think that's another another positive. A point of improvement can be that the volume of documentation, especially at the start, can feel disorientating for some people. I think that a way you can improve this is by having maybe in those longer documents, maybe a little flag on each page saying this is super relevant to the web dev team or this is super important for everyone, just so they don't have to read through the entire document. But overall, I thought this program was super well run. It was a very rewarding and valuable experience, and I'm very grateful to have the opportunity to be a part of it. And I'll pass it back to Manish for future work.
Okay, just to wrap it up, the demo pipeline is working end to end. So the future work is mainly about making this easier to adapt and more scalable for research teams. For future data ingestion teams, a big win would be to package the metadata generator properly. First, as a clean Python package so that the installation is one step, and ideally also as an R version since R is still very commonly used in research. Another important direction is expanding support for files where sample IDs aren't in the file name. So the tools sometimes need to read inside the file like we did for the counts. And related to that, the HTML preview could also be improved for files that map to many sample IDs so it stays readable and useful. For the future web development teams, the main opportunity is moving more of the metadata knowledge into the data registry itself. So for example, patient to sample mapping could live in the data registry rather than in a local config. We also don't know yet have a workflow to generate and download the config files from the registry, which would remove a lot of manual setup. And finally, there's potential for an API connection between registry and the generator, but that needs to be designed carefully because authentication and security become real concerns, especially for a command line tool. Moving on to acknowledgement.
Yeah, would like to acknowledge Roland again for being such a good supervisor to us and just being so supportive for us. Would also like to acknowledge the past interns of REDMANE and more specifically the data ingestion team. Without their previous work, we wouldn't have achieved as much as we did this intake. We would also like to acknowledge the other REDMANE interns, more specifically Amanda and Patrick, just for getting all the REDMANE sub-teams organized and working together. Thank you.
Thank you.
Thank you very much. It was really nice to see how you all grew and collaborated together. I feel that maybe early on it wasn't really clear how everything would fit together. And over the course of the internship, it was really nice to see how you gelled as things went through. So and it shows in terms of the outputs that you've put together. I can see how the quality and the accessibility is improved. So well done.